Day 2, Piecewise Functions with Mr. Taylor.
So if we start right on our day 1, this should be page 4 of your notes. Two variables have a proportional relationship if their respective values are always in the same ratio, which means they have the same relative size to one another. In equation form, we can write this as x1 over y1 is going to equal x2 over y2. If we look at an x or y, so all it means is the first relationship would be one on top, on bottom. The second would be on top and bottom. And then it's just important to make sure, right here we're talking about x's. If you're talking about money, the money's on top. If you're talking about miles, they're both on top. And then whatever the other things you're talking about would go on the bottom. In this case, it's y's. So let's see if we can put that into application here. At a local farm stand, 6 apples can be bought for $4. So determine how much it would cost to buy the following amounts of apples. Round to the nearest cent as necessary. So like we just talked about, we know 6 apples can be bought for $4. So if we start with 6 apples over $4, we want to know a dozen apples. So we have to figure out first off a dozen is 12. So it's 12 apples over, we're not sure how many dollars. So again, it's important to make sure apples are on top, money's on the bottom. So now we can go ahead and cross multiply these. 6 times x is 6x. 12 times 4 is 48. Our last step will be to divide both sides by 6. And we find out that apples would cost us, why can't I do this in my head right now? 8, right? Yeah, $8. Sorry guys, bear with me. Alright, so same thing for the 20 apples. We start with the 6 over 4, because it's 6 apples for the $4. We know that's going to be 20 apples for, we're not sure how many dollars, so we'll call it x again. Okay, so upon doing that, cross multiply once again and get the 6x. Cross multiply here, 20 times 4 is going to be 80. And then dividing both sides by 6, you'll end up with x equals 13.33 repeating. So we'll call it $13.33. So again, we're just using these proportions for the relationships to show it. So if we wanted to just write this in a general form, if C is the total cost of apples and N is the number of apples bought, can we write a proportional relationship between C and N? So if we're saying 6 is the number of apples for $4, that means we have the apples on top, or the number of apples on top, and the cost, or C, would be on the bottom for filling out a general form. This also then asks us to solve this equation for the variable of C. We can do that. It's not too difficult. If we want this C by itself, we're just going to start the same way. We're going to cross multiply. 4 times N is 4N. C times 6 is 6C. If I'm trying to get the C by itself, I have to move that 6. We divide it from both sides. 4n divided by 6 doesn't reduce or simplify for us, so we're just going to leave it as 4n over 6 equals C. This would be our equation. Now, ask us to graph it. This can be simple if you wanted to use your calculator. You can plug this right in your calculator. You would just substitute x for n and y for c. So what you would actually put in your calculator to graph would be y equals 6x over 4. The other way to look at it is, we don't have a variable here, so our y-intercept would be 0, and our slope is going to be up 6 and over 4. So if we do that, we can go from here, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. Sorry, I wrote it backwards. My bad, guys. We had 4 over 6. This would be 4 over 6. My apologies. So my slope would be 4 over 6. So it would be up 4 over 6. And we can keep doing that the whole way because it's a linear equation. One, two, three, 4, 5, 6. So there is our graph. And then lastly, it says, according to our graph, C of 15 equals 10. So if we look, 15 equals 10. Okay, so my line's a little crooked. C of 15 equals 10. What does that mean in terms of apples and money? So that's saying 15 apples would cost $10. So at this time, if you would, please go ahead and pause this video and go through exercise 2, A through D.
This is what you want to be doing in your note packet.
Alright, so we'll run through this quickly. Again, I'm just going to kind of go fast because hopefully you have this on your own. So, Erica's driving at a constant rate. She travels 120 miles in a span of 2 hours. So it would be 120 in 2 hours. So we want to know, she would travel how far in 3 hours? So we go ahead and cross multiply that quickly. We would have the 2x here. 3 times 120 is 360. We would then divide by 2. And we get x equals 180 miles. So if we write the proportional relationship for this, we started with the 120 over 2. So it's the distance d and the time t. So we have the distance is here on top, and the time t is on the bottom. And then it says solve the proportion for d. So we want to get d by itself. So we will cross multiply. 2 times d is 2d. 120 times t is 120t. Then you would go ahead and divide both sides by 2. You really have two options here. You can leave this as the 120t divided by 2, or we can go ahead and simplify it, and we would say it is 60t. That's probably the easiest way to go ahead and do that. So if we look at this and it says, what is our proportionality constant? Our proportionality constant right here is also known as our slope. So if we look at the slope of this equation, my slope is going to be 60, and my units is going to be miles over hour, or as we call it, miles per hour, or mph. So it says, how much time will it take for Erica to drive 150 miles? So if this is our formula, we want to know the distance is 150, so we can plug that right in. 150 equals 60 t. Solve that, we would just divide both sides by 60. And you get t equals 2.5 hours. It says go ahead and graph the function. So graphing this again, there is no y-intercept here, so we're going to start at 0. And our slope would be up 60 and over 1. So 20, 40, 60, and over 1 hour. Just don't get caught up. This is counting by 20s. This is counting by quarters. So make sure that you're going up 3, which would really be 60, and then all the way over here to 1. So you do it again, up 60, so 20, 40, 60, and over an hour. 20, 40, 60, over an hour. This would be our linear model. Alright, and then what does the constant of proportionality? We talked about that. It represents the slope of the graph. Okay, and then lastly, we're going to talk about a unit rate. So proportions where we compare the change in one variable to the change of 1 unit in the other variable. When we typically report speeds in miles per hour, the unit rate would be 1 hour. So when you say the fat has 6 calories per gram, it means it's 6 calories in 1 gram. So our goal in finding a unit rate would be to break this down into 1 unit. So if we have 24 feet per 3 seconds, I want to know how many feet would it be in 1 second. So you would solve that. Alright, same thing here, 30 pounds per 8 boxes. So if it's 30 pounds per 8 boxes, I want to know how many pounds would it be per 1 box. Take a second, pause the video, solve these first 2, and then set up and solve the third one. And when you start it back up, we'll finish the thing and you're done for the lesson today.
Okay, so you want to be filling in this section of your notes. When you're done with that, you can move on to day 2 homework for piecewise functions.
So if you have these all set up and done, you'll end up with, when solving this, you'll end up with 6, and our unit rate would be feet per second. Our unit rate here would be 3.7 pounds per box. And setting this one up would be 50 calories over 20 chips, so you'd end up with 2.5 calories per chip. This should set you up pretty nicely to complete day 2 homework. Good luck and hope things go well.